Hi guys, so today we're going to be looking at Chapter 3, Section 5, Solving Nonlinear Systems, Part 2. So today we're going to be looking at the nonlinear system, which is the circle or equation of a circle. The equation of a circle is x to the power 2 plus 9 to the power 2 equaling to r to the power of 2. We say that our x comma y, so the vertex here, the point on the circle is the following, x comma y, and r stands for the radius, so the length of the center all the way to the edge of the circle. The idea here is that when we have a line and a circle intersecting, they can intersect in the same amount of points as a line and a parabola. So for example, over here you can have either 0 points, 1 point, or 2 points. 0 points meaning that they just never intersect. 1 point where the line is intersecting on the edge of the circle. And then 2 points is when the circle is, or the line is intersecting with the circle. And then you see that there's 2 points being given. But most it would only intersect 2 times. Okay. So let's check out the first one. The first one is asking us to solve a nonlinear system by using the substitution. If I'm going to use substitution here for the following equation, x to the power 2 plus y to the power 2 equaling to 10, and y equaling to negative 3x plus 10. First thing that I'm going to do is I'm going to substitute this entire expression here into the y variable. So when I do that, my x to the power 2, which is right here, x to the power of 2, and y to the power of 2 equaling to 10, that turns into x to the power of 2 plus parentheses, and I'm just inserting this negative 3x plus 10 into the equation and substituting for y. Negative 3x plus 10 to the power of 2 equals to positive 10. So from here, all I'm going to do is start solving for the following. You have here negative 3x plus 10 to the power 2. I'm going to FOIL it, and I'll FOIL it on the side. So we have here negative 3x plus 10 to the power of 2. I could split it up into two different expressions, negative 3x plus 10 times negative 3x plus 10. And when I FOIL it, that means I'm just going to distribute the negative 3x to the other negative 3x and the negative 3x to the 10. Same thing over here, distribute the 10 to the negative 3x and the 10 to the 10. When I do that, I get negative 3x times negative 3x. That equals to 9x squared. I also have here negative 3x times 10. That equals to negative 30x. 10 times negative 3x. That still gives you negative 30x. And 10 times 10 equals to 100. So now I'm just going to write that down in my expression here. So x to the power 2 plus, and my FOILed out system is 9x squared minus 30x plus 100 equaling to 10. And so I could just start combining things together, since if I were to have like a plus, that doesn't really do anything, so I could get rid of the parentheses. When I get rid of the parentheses here, I can start combining the like terms that I see. I have here x squared and a positive 9x squared. That gives me 10x squared. I also have here negative 30x and another negative 30x, that equals to negative 60x. And I still have the plus 100 equaling to 10. So from here, all I want to do now is get rid of the 10. Subtract 10 on both sides. When I do that, I'm left with 10x to the power of 2 minus 60x plus 90 equaling to 0. And then since I see that there is something I can factor from all three, I could take out a 10. I'll do that first. So I'll take out a 10 from all of them. And if I factor out a 10, that means I'm dividing each term by 10. When I do that, I'm left with x to the power 2 minus 6x plus 9 equaling to 0. And then all I'm going to do now is divide both sides by positive 10. When I do that, I'm left with x to the power of 2 minus 6x plus 9 equaling to 0. And so from here, I just need to find out the two solutions by factoring out. I'll use the cross method. So by using the cross method here, we have 1 times 9 on top, that equals to positive 9. And the b value is just negative 6. So from here, multiplying these two numbers on top, adding the bottom number. Two numbers that would multiply to get 9 and add to get negative 6 would be negative 3 and negative 3. So I could use those two numbers. So right here, I get parenthesis x minus 3, and x minus 3 is equal to 0. So I'm left with x minus 3 to the power of 2 equaling to 0. Then from here, to get rid of the square, all I need to do is just square root on both sides of the equation. When I square root to both sides of the equation, I'm left with x minus 3 equaling to 0. And then I'm just solving for x. So right here, all I'm going to do is add 3 to both sides. And I'm left with my final answer, x equaling to positive 3. So now that I have my x value, I can find out what my y value is. All I'm going to do is just pick either one or the other equation from the very beginning. I'll pick out this one. This one seems to be an easier one to substitute. So we have here y equaling to negative 3x plus 10. And I'm going to take my x equaling to positive 3, plug it into the equation. So when I do that, I'm left with y equaling to negative 3 times positive 3 plus 10, and y equals to positive negative 9 plus 10, which is just y equaling to 1. So that would be our y value. This is our x value. So when I write my solution, we only have one solution. And that one solution is going to be 3, 1. Done. Okay, so for the next one, we're going to be asked to solve the quadratic equation by graphing. So right here, we're asked to solve the equation by graphing out x plus 4 times x minus 1 equaling to negative x squared plus 3x plus 4. First thing I want to do is to separate these two equations into one equation into two different equations. So I'll separate the first one, which is the parenthesis x plus 4 times the x minus 1. So I'll get here y equaling to parenthesis x plus 4 times x minus 1. The other one that I'm going to be separating is the negative x squared plus 3x plus 4. So we have here y equaling to negative negative x to the power 2 plus 3x plus 4. Once we do that, I'm just going to use specifically Desmos graphing calculator to find out the solution. So if you search up Desmos graphing calculator, you should be able to identify the graphs of these two equations. So if I were to go to Desmos graphing and I were to type in those two equations, the first one was y equaling to parenthesis x plus 4 and parenthesis x minus 1. The other equation was y equals to negative x to the power of 2. Then we also have here plus 3x plus 4. You can see that our graphs are intersecting at two spots. The first spot we have, and I'll take a screenshot of this first, and then let's move back to the notes. So all I did is take a screenshot, and I'll post the picture right here. Okay, so if you see this picture right here, it shows our graphs that we got. We have here the points that are intersecting. I noticed that there is one intersection shown right here. There's also, now let me highlight it. That might make it easier. So we have an intersection here, and we have another intersection right here. So what I want to do is I just want to identify what the x value is for them. So in this point, if I were to draw a line going all the way down to the x-axis here, oops, dragged up. So if I were to draw a line going all the way down, I get this point right here, right? That point is supposed to be the point where the first intersection occurs on the right side. And that intersection is for 1, this is 2, 3, 4, and 5, right? So this one was located at x equaling to 2. And the second intersection, which is identified right here, this one happened at, let's see, this was -1, this is -2, -3, -4, -5. So it did occur at x equaling to -2. So those would be our two solutions because they're telling us the location based off of the x-axis of where our two drawings were intersecting at. Cool. So now that we know how to use the graphing method, one thing that's really important is that because during the test you won't be allowed to use any graphing calculators, we should also learn how to solve this equation without graphing as well. So without graphing, what I want to do is start by solving for x. And the way that I could do that is starting off by following out this equation here. We have here x plus 4 and x minus 1. From here, I get x, let's see, actually, we get here x multiplying with x multiplying with -1. 4 has to multiply with x, and 4 has to multiply with -1. So this becomes x to the power of 2 minus x, x times x, which is x to the power of 2, and then x times -1, that equals to -x. We also have here 4 times x, that equals to 4x, and 4 times -1, that equals to negative 4. So our new expression will be x to the power of 2 plus 4x minus x minus 4. And if I were to combine like terms, I get x squared plus 3x minus 4. So my new expression should be x to the power 2 plus 3x minus 4 equaling to negative x to the power 2 plus 3x plus 4. And I'm just going to move all of this expression to the left side so that I can combine them together. So I'll start off by moving the positive x to the power 2. When I move the positive x to the power 2, I get 2x to the power 2, drop everything else down, 3x minus 4, equaling to 3x plus 4. Then I'll move the 3x to the other side. When I move the 3x to the other side, I'm left with 2x to the power 2. This turns into 0, so I drop down the negative 4. This becomes 0 as well, so I get just positive 4. And then, finally, I'm just going to subtract the 4 to both sides. When I do that, I'm left with 2x to the power 2 minus 8 equaling to positive 0. And then I just solve for x. So I'll add 8 on both sides. When I add 8 on both sides, I get 2x to the power 2 equaling to 8. Then divide 2 on both sides. And I'm left with x to the power of 2 equaling to positive 4. So from here, last thing to do, I just need to square root x to the power of 2, both sides. So on that side, and I also have to square root on this side. And so I get here x is equal to plus or minus 2, which was also the same answer that I got when I found it by graphing. We got two answers, which were x is equal to positive 2 and x is equal to negative 2. So hopefully this helped. Good luck.